All right, so we're going to get started. So this is a talk that I first gave in Stockholm at a Microservices conference and has been accepted to 2 other conferences. And it's also a message we've been talking about in Boulder, and I just found out LA is doing this without us knowing about it. And it really is nothing new. This migration is the way, old used to write applications. I think Rails kind of got us in this somewhat bad habit where we just kind of dump everything together. Engines are an option, but they can be a little tricky. So I'm going to show you kind of my running hypothesis around this. So this came about, we did a proof of concept for a client where they had this gigantic monolith all written in Ruby and Rails, written by a bunch of contractors. It was literally the future of their business. So this app was like, if they didn't make this app work, they were going to go extinct. Netflix was going to eat their lunch. So this was a very big thing for them. So that's where this comes out of. I've been working on the Spring Cloud Services team for the past 8 months. This was a choice that I made because I wanted to learn more about Spring, and I knew a friend of mine who was the product owner. So I felt like I needed to be able to talk about this stuff as an expert, and not trying to be a chief principal consultant scientist. So a lot of this microservice stuff there's a lot of hype around microservices. I've seen it. I've talked to clients about it, but really trying to make this this is how we are going to do things, and I'm not trying to sell you this. I firmly believe that this is the way this is going to go down. There are two sides of the coin of this. Is clients want this stuff. They're asking for it because unfortunately microservices have one of the biggest marketing departments next to like Docker. There's all this buzz in the community about microservices, and that's good. We want that because I think microservices for a lot of our clients in the long run are going to be a better architecture, but it may not be right now. It may not be in the state where they're in. So there's 2 sides of this coin. So a lot of people are migrating monoliths. This is a big thing. Most of our clients come to us and say, hey, I have this gigantic WebSphere installation where I'm scaling it horizontally with like 40 instances, and it takes us 75 minutes to deploy to production. This is a real thing. There are a lot of people that are actively migrating these for the better or worse success. There are also companies that are building microservices right now. So I talked to a company called Klarna when I was in Stockholm, and they had actually built microservices from the beginning because they had a failed monolith and they knew what they were building. So I think microservices are good for some companies and not great for others right from the get-go, and we'll kind of talk about why that is. So we'll go through a background. So there's a little history I'll give around this stuff, where it came from. The goal of this talk is to give a path. So literally, like, where do I start? How can we go into our clients and be like, hey, you're here. I kind of have an idea of what the next step is. And it's very logical. It's not hype-driven. This is evolution. So something happens to the system which forces it to change. And that force is not some developer comes back from a conference and says we should adopt microservices. It is very much driven by the business. And then we'll go through the path. So this idea was codified in Boulder by Mike Baranek, who is now VP of CSO, I think. Mike's been writing Java forever. He worked for GNIP, which was the company that was just acquired by Twitter because they could actually consume the fire hose, so gigantic scale applications. His idea was this continuum. So you start somewhere on this continuum. So you might be down here. So think Sinatra. I have 5 files in my application. I need no structure because there is nothing to structure at that point. And then as you move this direction on the continuum, you get more and more structure. So namespaces is the first one. This falls down a little bit in Ruby because of the way requires work and namespacing works in Ruby. You don't necessarily get really hard-sided boxes. They're a little bit more fluid because once I require a file, I don't have to require that again. So, and then I go to applications and libraries. I might have multiple applications in those libraries. And then eventually I've got microservices. But I actually kind of start with services maybe here because I've broken out libraries. So this continuum is the idea that I really actually like because it gives me a place to start and it gives me a place to stop if I want to stop. I don't have to go all the way. It's not an all or nothing type of migration. So like I said, This was done on a client project. They were super excited about it. We presented this to the CIO of the company and his senior VPs. And it was a lot of head nodding. I felt really good about that. Not in like I had sold them something, but like they were really like, oh wow, we're onto something. So I would love to continue to talk about this. This is why I'm giving this talk everywhere, because I want people to challenge this idea. Because I think that this is how we get onto this. So much that one of our office directors who now runs Berlin is writing a book on Rails for this. It's called Component-Based Rails Applications. So I think there's some stuff here. So some of the goals of this project, like I said, that monolith was running in production, making them money. So it wasn't like greenfield, start over. We were going to actually take an airplane that was flying and try to convert said airplane into something else that would take them into the future. They knew they needed scalability. So we're talking over-the-top television here. This is Netflix-style video streaming, so they knew they were going to have scale. So that drove some of our decisions for this. They also knew they needed multiple teams. So they knew this app was going to get big. They were going to have multiple teams. How did we enable them to do that? And then this was another big one. So they wanted to add resources, but they didn't want overcrowding. So one of our goals was to kind of give them that. So yeah, so those were the goals of the project and kind of drove this architecture. If people have questions along the way, we have to be out of here by 3:50. So you can ask them, but I might ask you to hold on to the question. We can talk about them afterwards. I also prefer questions, so don't be shy. And I always forget that I've done the highlighting on these, so I end up having to blow through those. So the current state of the app, multiple API servers, multiple clients, including JavaScript, plus a bunch of set-top boxes, plus a bunch, like Xbox One had a client that they had written. This was the scariest part for us. They told us that somewhere a non-trivial amount of the code was just no longer being used, but they couldn't tell us what. So that was fun. We heard numbers of somewhere like 35% of the code was not being used, so sizable, and lack of any comprehensive safety net of test suites. So, not untypical of projects we're going to see going forward. So that made us sad, but in a way that we could help them. There was a little bit of fear too, because when you're migrating production applications without tests, that gets a little scary without safety nets. This is my favorite quote, and I find myself using this more and more in any discussion I have about these architectures, is it just really depends. You go in, you have to look at what they have, and then you're making a game time decision as to what the next step is, which is one of the reasons I like this stepwise approach, because there's no right answer. I can try a bunch of tools and see what happens. So which comes first? Like I said, I firmly believe that microservices are the future for a lot of these big companies. We know that the architecture is good. We've seen what happens when people do it well, but I'm not convinced we start there. I like this well-structured monolith idea, where you've got these like very vertically sliced silos of functionality that you can then shift around in your application. And kind of where you start depends on how much you know about those vertical slices. So if you're a bank that's been doing banking for 30 years and you're just rebuilding a legacy application, you might know exactly what that app looks like, because half the system may have not changed in 5 years. So maybe microservices make sense then, but if you're a startup, it doesn't make sense. I was just talking to a friend of mine at a startup in Boulder called Wonder Capital, and they were like, yeah, we're going to do microservices. And that was like 3 weeks ago. I had lunch with him right before I left, and he's like, hey, we've decided to go to a well-structured monolith. And I was like, yay. Because he thought that gave them the best benefit balance for functionality. And it was really exciting to see, because he was super stoked on microservices for a while. And I think that's what we will be fighting a lot of that as we talk to clients, because their developers are hearing about microservices and they want to do microservices because microservices are cool, and monoliths not as cool sometimes. But I actually kind of like boring, so that's okay. So the path, safety first. This should probably be not a surprise to anybody, as we were going to decide to write tests. So sometimes when you do these, you feel like you're walking on a tightrope with people on your shoulders. So our goal was to write tests for this first. And our goal was to make sure we don't break anything. So it's this analogy of the plane is flying along. You have a couple of options. One of them is to land the plane, rebuild said plane, and then take off again. That wasn't an option for us. So we were literally going to pull a plane up next to it and just start shuffling passengers across into the second flying airplane. Kind of dangerous without a safety net. So this is what the current API looked like. So you get this big box, treat it like a big black box, all the clients are hitting that. So we decided we were going to start there with the tests. So we were going to start at these acceptance level tests to assert customer facing behavior because we couldn't refactor anything. We wanted to make sure we didn't break anything. So we looked into a library called Pact.
We used that too, so that was it. I just said, oh.
Oh, you used this?
Yeah.
How did you like it?
It was good.
Yeah, that's how we felt. We're kind of like, it was, I think there's some work to be done here. This was written by ThoughtWorks out of a project in Australia. They also had a Brazilian project write something very similar. Yeah, so what this is where you start to define contracts between your services. So what's the first thing you do when you're writing a JavaScript front end is you write a mock server that serves up just dummy JSON. And then the first thing you do when you write a backend is you write some sort of test that says, hey, when I give you this request, I expect this JSON back. This stuff allows you to create these contracts in JSON such that you can share them. So you don't have to write both sides of those. You can then just share them and have the code write the server itself. And these are defined by the client. So the client of that thing defines what contract it is expecting. This is then run in the test suite of the producer to make sure that they never break that contract. So we wanted to assure we didn't break anything. And we wanted to know really quickly when we had broken something. Because again, you're flying that airplane. Before you take that next passenger, you want to make sure there's a seat for them. We had mixed reviews on this. We thought the Java library was a lot better than the JavaScript library. We just kind of struggled getting the JavaScript library set up to do this. The Ruby one I hear is much better just because more of the work had been done in Ruby. And it was good? Yeah. Yeah, I think, like I said, I think there's some more work to be done here. I think the idea is sound. It's just now the implementation. There's a little bit of work to get that done. So we started here, and this should be a no surprise to anybody.
Without a comprehensive test suite, how did you ensure that you had written a comprehensive test suite?
Great question. So we would propose this as a POC. It would have been one of those where we would have just tried to get as best we could and then been conservative going into production. It's super hard. This was the biggest risk we identified to the client. We're like, hey, we're going to do our best here, but you're telling us there's dead code. You don't really necessarily have a product owner for this. It kind of was product designed by committee. You know, it's one of those things you're like, well, we might drop a few here, and we got to be okay with that. So being conservative. Were you and I talking about this, Gabe, about the clean code thing? So this is the Uncle Bob. I want to be able to open up your application and go as few levels down to see exactly what the application does.
You're browsing the source?
The source tree, yeah, the source tree. So you crack open this application and it's not models, views, and controllers, and you don't say, oh, that's a Rails application. You look at this and go, oh, I'm dealing with hospital data here, or I'm dealing with car manufacturer data here. So unfortunately, this is what we get out of the box in Rails, but you can write a Spring app that looks just like that. And you're like, yep, that's a Rails application, or yep, that's MVC, pretty much. If I need to make a change to the user domain here, what is the maximum number of folders I may have to go into to make that change? 3. I have to go into at least possibly 3 folders at some point. In this, how many folders do I have to go into? Hopefully only 1 if I've done my job right. So this is the idea of you're just gonna, now it's not the top level directory because of Java's wonderful packaging mechanism, but at some point I get to my domain. And I organize them such that my web application sits outside the domain. So the nice thing about this is if I get my bounded context wrong, I'm now just shuffling files in between directories, as opposed to taking a file from microservice A and possibly shipping it to microservices B's Git repository. So the idea here is to make the cost of change as low as possible while still getting the benefits of the organization. So interesting here, we've actually dropped the controllers in here. I go back and forth as to whether or not controllers, where those live. If you've studied hexagonal architecture, there's this whole idea of ports and adapters. I see those as adapters to HTTP, where my user class would be my actual domain, which I own. So my goal was to see them. Number one is I minimize the number of directories. So I've already started to create space for more development teams. Theoretically, if my story is very focused on one thing, I may not touch another directory and I could put another team in that directory. Still not big enough for a lot of people, but a little bit better. I can do this experimentation. So I'm not worried about being wrong with my bounded context. I just make a guess and like, okay, maybe it sits here for a while. And then I realize that users need to go with orders for some reason, or user needs to be split in half. This is another one that I love, is I'm delaying architecture decisions. So I'm waiting as long as possible to delay architecture decisions, because inevitably tomorrow I will know more than I know today. So there's two ideas when making architecture decisions. I don't remember who said this, but one of them is delay them as long as possible. And then the second one is when you have to make them, try to make them reversible. So in this case, I'm just delaying them so I don't have to make them reversible. And then I like the apps can just sit here for a while. As they grow, you add files and you kind of figure that out. So I kind of like this first step. So now I get to the point where I want to break out components. So the app is growing. I'm getting more domain boundaries. So I'll show you what that looks like here. Oh man, that's going to be... So let's pull this over. So what you start to do is you have an application. That application has some Java files in it. And here I've made the decision to leave the controllers in the application. We have a couple of us in Boulder who actually say the controllers should go with the domain. My idea is that if it's a port to the outside world, it's HTTP, I'm going to leave that with the HTTP stuff. But then I'm going to start to break out my components, my different domain folders, into actual Java components that have their own build.gradle. So you could build this jar file, publish it as an API, and go that route. We don't publish them. They just get included in this build.gradle as project dependencies. So when I build the user management system, it's going to go ahead and build those for me. So this is what I mean by components. They are separate jar files. They have boundaries. Any ideas of what this gives me from an organizational / code quality standpoint? Composition, so I can start to compose them.
But I guess you also get lots of capability for reuse, and you migrate those jars to other applications.
So reuse is an opportunity here, not necessarily the number one reason I do this.
Gives you a nice dependency graph.
Dependency graph. I want a monodirectional dependency graph. I want everything to go one direction. If I get a circular dependency between those components, they will not compile. Unlike in Rails, where if I make an association, I love that you're nodding your head at this stuff. You and I are like kindred spirits. You know, the first thing the Rails book tells you to do is when I do a has many, I do a belongs to, and I've now just created a circular dependency, and this is why users can never be extracted from Rails applications. But this will stop me from doing this. So I create a one-directional dependency graph. And the compiler will be like, hey, I don't know how to compile these because they're dependent on each other. So that's really cool. A little bit more work. So in trading that benefit, I still have a little more work to move files around. So I get a benefit, but I also have a cost associated with that. And I'm making that it depends decision as whether or not the cost is greater than, or the benefit is greater than the cost. And in this case, I think it is. So these are, not super exciting. This is an interesting pattern I've been experimenting with, is having use case examples. So not having services, because everything's a service these days. But these are use cases in Java. They're just method objects. So interesting little toy I'm playing with. We'll see how it goes. Now we come to databases. The age-old question of who owns the database. Does the application manage it? Do the components manage it? It depends. We were actually having a discussion this morning on Twitter between Mike Baranek, Stefan in Germany and I, and Damien and back in Boulder. Mike has actually postulated that you have a third top-level directory called databases, where those have their own place, and you enforce one application per database or one component per database. They're tricky because who runs migrations and how do those life cycles get managed? Stay tuned. Eventually, someone will come up and or maybe not. Maybe this is one of those things where you're just going to have to make an engineering decision on who's better off managing that stuff. The one rule we do love is migrations only touch one table. And why do we make that a hard and fast rule?
Because then you componentize your deploys.
If I have a migration that touches two and those tables go two directions, now I have to split that migration up and they're impossible to run from the beginning. So Stefan, I think, was the one that came up with this one as he was writing his Rails book, because he was breaking his migrations out into engines and running them with the engines. So that's the one hard and fast rule that we try to stick by, is you just touch one table.
What if the migration involves adding a column and adding a column? Sometimes it does touch two tables.
So foreign keys are interesting in this component-based architecture, because when I go to services or the goal, I can't do foreign keys. So you have to kind of figure out how that goes. DHH will tell you that we don't need foreign keys in databases. I kind of like foreign key constraints. Make a decision. Not putting them in gives you a little more flexibility around being able to split those if they go different directions, but not having them, there's a cost, because now I can't let the database enforce foreign keys. Like I said, this is still the most wishy-washy piece of this presentation, is what happens at the data layer. And it's hard, and it's super important, because the data is really the important thing. The apps come and go.
So this is for the case when you're migrating a monolith.
Yes.
If you're adding some new code and you decide that, okay, my app is currently component based, but I know that this is going to be separate, how would you structure the data?
If you're starting a new database, so you know, like, oh, I'm gonna put this in a new database, or let's say I'm going to Redis as my data store. I'm not even going into a relational database. I've decided that this is a Redis or a Mongo thing. That makes it a little easier, because in Mongo I don't have anything to migrate. I guess it depends on what you end up with. If you're going to relational, now you have a decision to make. If you're going to Mongo or Redis, there's no data layer for that. There's no DDL. There's no migrations for that. So this is still the fuzzy part, and because microservices give us the ability to do multiple data stores, you have to kind of just play it by ear as to what happens. So I'm now getting myself more room. I now have separate directories that people can live in. So I'm giving myself more room. I'm getting those stricter boundaries. So the walls started out like rice paper walls when they were in the same code base in different directories. I now have maybe plywood walls between them. And at some point, I'm going to have cinder block walls between them when I go to microservices. So I'm just moving the code base farther and farther away from itself, trying to see what happens. I get kind of microservices-ish. You could actually make the argument that I do have services. They're just they're in-process services. They're not cross-process services. So I'm able to get feedback on how the code wants to be stretched in different directions. And I can stop here. You could literally leave an app sit here for a while. You don't have to go to microservices. So now the magic happens. Now I've decided, for some hand-wavy reason, which will not be talked about in this talk, I have now decided to extract my first microservice. And everybody's like, well, that's the exciting stuff. I'm like, that's exactly why I'm punting on this. So you've decided that maybe you've got your bounded context. So your payment service has some sort of requirement that it needs to be broken out. It's a scaling requirement or something else. You might want reuse. So reuse is not a primary driver for microservices, but it might be a driver for this. So you might want some reuse. Sam Newman has a great book called Building Microservices. He works at ThoughtWorks. He's got, I think, 6 or 7 reasons why you would break out a microservice, and they're all different. It just really depends on what the client needs. But you have decided to do this. The magic is now happening, and everybody is super excited, and it's a pretty big non-event. Really, once you've done all the hard work of microservices. You have the boundaries you need, hopefully. So I now am going to break out a billing service. So the first thing I need for a billing service is a free running process, and the first thing I do when I create a free running process is create a README. So you're seeing the README. I now have to build the process. So here comes build.gradle, all of my fun stuff. So I'm incurring some cost here now. I have some cost to do this. This is not free. I now need an application.java, which Spring Boot luckily gives me a pretty easy way to do. I've got some configuration here. So I've got some beans, pretty boilerplate. I now need a controller because I now need a way to take an HTTP and express my domain out into the world. So I do that. I have some configuration. I have to tell it what port it lives on. And now the main app loses its component. I simply pluck component from one app and put component in second running application and wire it together in the controller. I also gain one more thing. I also gain the mechanism to communicate with that free running process. So I no longer get that for free. I now have to go talk HTTP to this thing over the network. So I need a client. So there's more cost there. I now have to write more code. I have an endpoint. So I now need to tell said existing service where said new service lives. And then I just start mucking with the controller to slowly extract that stuff. The nice thing though is I'm now swapping the client for the domain, for the use case. So I'm just swapping that out. So it's a relatively clean extraction once you've done the work. The rest of this is simply moving stuff around. So not hard. You incur some costs, but you get the benefits. And now it's like, well, did those costs outweigh did the benefits outweigh the costs? And that's it. It's a lot of boilerplate, just shifting stuff from point A to point B. You'll notice we keep these all in the same repository. Does anybody want to fight me on that one? The reason we do it is I'm delaying another architecture decision. It's just less cost to shift that out. Everybody knows that Google runs one giant repository. Depending on who you talk to, whether or not that's a good thing or a bad thing. I mean, some companies are doing it, some companies aren't. We decide to do it. Baranek's a huge proponent of this. I don't know. I kind of like it. But if you wanted to split it out into another repository, you could very easily do that. So my costs. I now have a communication cost. I also have now reduced the cap theorem to the CA theorem. Because when I go to a distributed system, I no longer can ignore partition tolerance because the network will fail. I lose the ability to choose whether or not I have partition tolerance. I have to have partition tolerance. So those are the...
Do you want to just cover all of cap really quickly for people?
Yes. Consistency, what's the availability, thank you, and partition tolerance. So consistency being that when I make a write, it actually says, yep, I've gotten that thing. Availability is like, hey, can I talk to this thing? And partition tolerance being the network will go down, I now have to somehow deal with that. So now we get our first pattern, service discovery. So I now need to know where that thing lives and how many instances there are. So if I'm hard coding ports and IP addresses, and I have 12 of them, and I go to 13, what do I have to do? I now have to go tell said consumer or multiple consumers that there is now a 13th one. So service discovery is the pattern that abstracts it away from me, so nothing can't be solved by another layer of abstraction. So luckily, Spring Cloud gives us some of this. So I now start pulling in Spring Cloud Netflix code. The actuator is required simply because Eureka requires the actuator. It uses some of those endpoints. And I'm using Eureka, so those of you that are going through the training, you will see at some point how Eureka works. Downside of this is I now have more code to deal with, so costs are starting to pile up. I also have another free running process that I have to manage, so this is where Cloud Foundry gets kind of nice. I don't have to provision a server to go run this thing, I can just CF push it. So I'm enabling the discovery client, so this is now starting to register the applications with Eureka. This is the thing I love about Spring Cloud and Spring Boot, is it's one annotation. The other cool thing about Spring Boot with regards to the Netflix stuff is the Netflix team is actually now using the Spring Cloud stuff internally. So they wrote Eureka, they wrote all this stuff. We wrapped it up in a nice Spring bow, and we now given it back to them, and they're using it. Kind of interesting.
How much work would it be without that one annotation?
I've never looked into that. I've never gone and been like, oh, how do I configure a Eureka client? It's probably relatively easy. The Hystrix stuff I know is a little mind-bending to deal with that, and Hystrix is one annotation too. So these changes are a little bit of just changing stuff so I can pass them around, a little bit hand-wavy. I now have to tell the application what its name is. So when it goes to register with Eureka, Eureka says, oh, you're a billing client. Okay, sweet. I'm gonna use that as the name. And I have to tell it where Eureka lives. So the nice thing is I've swapped URL hard coding for URL hard coding, but this URL is less likely to change than the other URLs I was hard coding. Because once you stand up Eureka, you don't really necessarily need to move it. And then here's the other app that is just simply getting the same treatment. So it enables discovery clients. That second line, line 18, is enabling Feign. So Feign is a mechanism given by Netflix to write declarative HTTP clients. So similar to JPA or Spring Data interfaces for repositories, it's that same idea. I just write an interface and Feign will actually implement that interface for me. The nice thing about that, what's the nice thing about that? Why do I want to not have to write a lot of code in a microservices-based architecture?
Because you're lazy.
I am lazy, yes, very much so. I also can't hide logic in the client now. So that's a danger of microservices-based architectures. If I want to do multiple languages, I don't want to put a lot of logic in those clients because then I have to duplicate the logic across them. I want to push it down into the service. So I'll show you the Feign client in a second. I now lose all of this stuff. That goes away because the endpoint's no longer hard-coded and the client is now a different class. Here's more of the Eureka stuff. Billing request is simply a POJO that I pass back and forth across the wire. And here's the client. So I tell the Feign client that it's going at the billing service. It will now automatically know that it's going to go to Eureka and say, hey, I need a billing client, and handle all that for me. And then I just write my interface. So I can be very lazy with these things.
Type of value equals reoccurring?
Yes.
Reoccurring, not recurring.
You are the first person to find that. Yeah.
Sorry.
No, that's all right. Okay, the compiler won't check that for me.
Your pair will.
My pair will, yes. So I really like these. Under the hood, it's using a client-side load balancing technology called Ribbon. So if Eureka were to ever go down, I now have a backup of the Eureka cache, and I can do that locally. So here's implementing that billing request so it can be passed. Here's now the other downside is I have a third free running process. I am now like racking them up I'm wrapping up application instances like nobody's business right now. Yeah. So here I now have another process I have to manage. So now if you're on PCF and you're running Spring Cloud Services, you don't have to manage this, thank goodness. We take care of that for you. So I now have that. So I now have 3 free running processes to have 2 things that actually add business value to my world. Okay, so I now have got additional complexity of things I have to run and or manage, but I get some increased flexibility. I now have a layer of decoupling. So now I have the circuit breaker pattern. So now I've handled the service discovery piece. I now know where everybody is on the network. As those services get scaled up and scaled down, I don't have to change anything. They just register themselves with Eureka. But now I have to handle the partition tolerance thing. So what you don't want is one service failing and having the whole thing go down. So you need to stop that. So again, we are going to go to Spring Cloud Netflix for a solution. I have a new service. I have a client. This service is mandated by Hystrix. Unfortunately, I can't do, well, I didn't used to be able to do Hystrix annotations on something that wasn't calling a method. So on a Feign client, I couldn't do Hystrix on top of Feign. I think that limitation's been lifted now. And I'm enabling the circuit breaker. So again, super easy. I'm auto-wiring my client. I'm auto-wiring my service. There's my service. I'm just shuffling the layers around. And now in the service, I have the method I'm calling, and I annotate that as a Hystrix command, and I just tell it what the fallback method is. And then I implement the fallback method. So if anything blows up here, it's going to automatically call that method. The rest of this is, again, just shuffling the service in for the client. So I'm creating another layer of abstraction.
Sorry, that service of yours, it doesn't have any annotation on it. Is that just a POJO?
Just a POJO. I just needed a layer to tie Hystrix to.
Circuit breaker to hit so that you can then...
Yeah, because I had my Feign client, which is an interface. I couldn't do my at default method on that. I have to go back and check. I think I can now. I think they've lifted that. So it was that layer. But here now I have a 4th free running process because now I want something to monitor all of my circuits. I want to know when this blows up. I don't want to just sit and wait because now I have microservices and I need to know what's going on. So there's this whole circuit breaker dashboard that goes in and says, oh, I have this big thing you can put up on a monitor just like we do a CI, and you can see the status of all the circuits. But now I have a 4th free running process, and I still only have 2 actual business services. So I've incurred that cost, a little bit more cost for that flexibility. So again, I've got one more of those things to monitor. It's going to fail, but I now have a backup. So I'm stopping that from cascading. One of the big examples of this is the Netflix recommendation engine. I guess that thing is notoriously flaky. So what they do is they use this. They just return you some canned list of recommendations for you if the service goes down.
So along that example, in your example of a billing service, what would your fallback method do?
I might send an email to somebody with like, here's the code. I mean, you'd have to figure that out.
In that case, you couldn't return any canned data.
You can return, so that might be a bad example, but there would be something of like, that broke, I now need to deal with it, versus like, wow, billing's important. It made me think about what I was going to do. I now need to sit and be like, oh, I didn't really think about what was going to happen when that billing service fell over.
Right, this forces you to...
It forces me to look at that.
Confront that.
Yeah, it puts it front and center, like, hey, this is a thing. And I increase the visibility of the health of the system as a whole, because as you're managing distributed systems, that's one of your number one important things is how is this thing doing, especially if it's your billing service. So the cool thing about this is I really think the first service is the most expensive one. And the costs start to level off at some point because now I don't need to deploy another Eureka server. I heard something at one point that Netflix runs like 3 Eureka servers for their whole infrastructure. And I think that's because they go cross AZ. So it's relatively scalable, so I don't have to do one of those. I also don't need to stand up another dashboard. I get one of those for free. So I can just continually extracting these services as necessary.
AZ, availability zone?
Availability zone, yeah. So Netflix runs on Amazon, notoriously on Amazon. So they run in multiple Amazon zones. Yep. So there are a lot of places you can go from here. You've done all the heavy lifting. Maybe you want a message queue so you can change the communication interface.
Instead of HTTP.
Instead of HTTP. So I want to go asynchronous. I'm taking data off connected cars, and I can drop a couple of those. Those cars aren't going to wait for a 200 response from my service. I just drop them into queues. This whole notion of distributed configuration. So if I have 30 services and each service has between 10 and 20 instances of it running, and I want to change the configuration on one of them, I don't want to have to go out to each one of those and do it. So Spring Cloud has a distributed configuration where I put them in a Git repository. I kick one of the services and it says, hey, go refresh your configuration. It tells all of its neighbors and it goes and does it. This is my favorite one, is just not do anything. So let this thing run for a while. And you kind of get the choice. So the whole idea of this evolution is I can start to make choices, very conscious choices, along the way as to when I'm going to move to the next step. And you can stop at any time. So a bunch of resources. These slides are up on GitHub. The code is up on GitHub. This was the original blog post that got me thinking about this. It's where those two structures came from as to how we organize this stuff. Baranek's website about the continuum, the Spring Cloud website. And then my go-to these days for microservices information happens to be Martin Fowler. Sam Newman is another good one. So he wrote the book on microservices called Building Microservices. This stuff is so changing that I can't keep up with it, so I end up just letting the experts keep up with it and then kind of digest that.
Right. So the interesting part of the architecture at this stage was that you mentioned perhaps change the communication to using a message service in the back end. That's interesting to me because I've always sort of felt that, and at least, correct me if that's not the case, that the message services and message buses was part of the legacy infrastructure. We're throwing that stuff out.
Yeah.
Microservice communication point to point is RESTful now with hypermedia, blah blah blah. Mm-hmm. Links embedded in them. Is that a legitimate option to actually, instead of having the point-to-point communication over RESTful APIs, to just throw a JMS or a message service at the back end?
Kind of. So where we went wrong with SOA was we put too much smarts in the pipes. So it's really not necessarily HTTP is the mechanism to communicate with microservices. It's dumb pipes. It's dumb pipe smart services. Where we went wrong with the message bus is we had smart pipes. Right. We had coupling inside of the message bus so that when I wanted to deploy two services, there was code here that was shared. So it's not necessarily HTTP. It's just that rabbit queue is dumb. It is simply a bucket that I dump stuff into, giving me the flexibility to do asynchronous. There's no logic there. Just like there's no logic in my HTTP clients. I want to make dumb pipes. And that's the key to microservices. That's what gives you the loose coupling where I can deploy microservices independently of one another. Yeah, and very valid. People ask that all the time. I was like, well, we did SOA. I was like, exactly. You did SOA. You put all your smarts in the plumbing, and now that's all broken. Any questions?
I have one.
Yeah.
So, how many instances of the service discovery service do you have? I imagine if the service discovery service goes down, then all bets are off.
Maybe. So on Cloud Foundry, you have a resurrector. So if I'm running Eureka as a free running process that is CF pushed, if it goes down, Cloud Foundry is going to notice that. The Diego is going to notice that and spin it right back up again. I also have client-side load balancing. So Ribbon keeps a cache of the Eureka map. So as long as Eureka comes back up before that cache gets way stale, I might be okay. So there is the risk that Eureka goes down, one of my service instances goes down, my cache is out of date, and I hit one of those. But Ribbon will say, oh, that one didn't work, I might go try another one. So right now in Spring Cloud Services, when you ask for your Eureka server, we give you one. So it's not HA, technically not HA. It's close enough. We're working on an HA solution, so Eureka built in from Netflix has the notion of failover. So you can spin two up, point them at each other, and they'll keep each other sane. The chances of both of them going down decreases. Very valid point. But you've gone to distributed systems, so now you have to think about that. Yeah. Yes.
How easy is it to swap in other sorts of service discoveries, such as console producing service discovery using OpenDNS and distributed configuration as compared to the ones that you just discussed?
So there are service discovery is a pattern. There are multiple ways to do service discovery. So one of them is DNS. The downside of DNS being is time to live problems.
Yes.
So that's one of the reasons people don't use DNS. In Cloud Foundry, technically, you could just use the router. I'm spinning up services, I'm scaling app instances. They all register themselves with the central router. The downside of that being is now I have a hotspot. Not as only is my traffic coming through the router, but now everybody's got to go through that router. Once I get to the layer of Spring Cloud, I now have a Eureka implementation, a console implementation. I think there's a Zookeeper implementation. So to swap those out, if you're using Spring Cloud, is relatively easy because they all look the same. I've never tried it. We only support Eureka for Spring Cloud Services, so that's the only one we've ever played with. But yeah, you could be like, I want console. I think we're working on support for that. I don't know when we'll have it, but it does exist in the open source bits.
Do you think another question you can ask after you split out the first microservice is, should we rewrite this microservice in a language that is most optimal suited for the problem we're trying to solve with this microservice? Or do you think that microservices should try to have the same language running?
Now we get to politics and religion. So yes, I do believe that once you've spun out a microservice, you now have the freedom to do that. You didn't in the monolith. So that might be one reason driving you to get a new microservice. You're like, I want to use a graph database for this thing. Or, you could use a graph database in a monolith, but I want to write this in Clojure Haskell for some reason. That might be a very valid reason for spinning that out. Now you have the decision of language choice, and is it worth it? So, some people will say your microservices are small enough you can rewrite them in X number of weeks, but you at least have the option. Now it's an engineering decision, you can have that discussion, whereas before you couldn't even have that discussion. Yes?
That might be an interesting exercise to do a polyglot microservice decomposition with something like a message bus in the back end to communicate across the boundaries.
Yeah, totally. You now have that flexibility and that freedom to do it. And that's one of the reasons you would go to microservices. I now have a different performance characteristic on that service. Or I have an engineer that wants to write Haskell. So that's how Wonderkinder got their first Haskell service, is a developer wanted to write Haskell, and there's Chad's like, sweet, go write Haskell. I'm like, knock your socks off. Anything else? Any comments of I saw a lot of head nodding, which is awesome. Any limitations of this? Anything anybody wants to challenge me on? Because I want to make sure this makes sense.
Does network latency ever become a problem?
It can. It's a cost. It is now a cost of microservices. So now if I'm going to microservices, now if I'm calling, especially if I'm calling multiple services, theoretically, these are all running in the same data center and you've got this gigantic, really awesome network and you don't have that problem. but it is a possibility. That's something that you have to, you have to measure and look at. Cool, sweet. So we're out of time. Please keep the questions coming, and we will continue the discussions around this and see where it goes. Awesome, thank you. You're welcome.